Hello friends, how are you all? I hope you all are in good health. So here I am back with another video for all the beginners. It is a very good video. The topic of my today's video is stellar evolution. Friends, before going into the video, please like, share and subscribe to my channel for more information and press the bell icon for tech related videos. Here I start. Molecular clouds. Journey of formation starts from molecular clouds containing H2 and He and traces of CO, NH3, H2CO, CS, N2H+, etc. Hence molecular clouds. Fragmentation. Molecular clouds are generally of the order 10^5 solar mass. This huge mass star so far has been found. Fragmentation process occurs, causing fragmentation of molecular clouds in smaller masses, each initiating its own process of star formation if conditions are met. Thermodynamics inside. As the cloud collapses, the gravitational energy is transformed to radiation, and this goes out by collisional exclusion of revolutionary level of molecular hydrogen and infrared cooling by dust grains. Hence the collapse is isothermal. Further, the star collapses under gravitational influence and until the star becomes sufficiently opaque to prevent further radiations and ultimately radiant like black bodies. This process is adiabatic. Fusion. Further collapsing of stars causes huge amount of heat generation sufficient to initiate the process of fusion of hydrogen gas to helium. The genetic disk. The swirling of dust around stars causing formation of a genetic disk called protostellar disk. The relative denser dust around forms planets through collision process. All this and more plays on a single physics formula: conservation of angular momentum. Main sequence star. Under the condition of hydrostatic equilibrium, outward radiation pressure is balanced by inward gravitational force. Types of stars. Our sun is a yellow dwarf and a type G star. Kind of stars we should know. Stars very low in mass are called red dwarfs. Stars like our sun are called yellow dwarfs or yellow stars. Stars very huge in mass are called blue stars. Their colors are as per their names, distributed as per hot body energy distribution. Herschel-Russell diagram. Observations made on kind of stars and their stages on temperature and luminosity. Question for audience. Which star do you think will have greater lifespan in comparison to their masses? Will star of greater mass live longer or the opposite? Although it may seem counterintuitive, but stars of greater mass have comparative shorter lifespan in comparison to stars lesser in mass, as more energy is required to be radiant out of the stars, like zero blue star maintaining its luminosity throughout its entire lifespan. For smaller stars like white, lesser energy is required in similar way. There's an end of every story. Eventually star runs out of fuel. Star collapse, further generating more, and thus fusion of helium begin forming denser elements. This goes up to the formation of uranium depending upon the mass of stars. Outer envelope expand further as gravity lost control over it. Stages of star until demise. How do they end? Every star its own of ending, highlighting the magnificence of the beauty of cosmos. Just radiates. That's it. Red dwarfs begin. The smallest star live the longest. Throughout their lifespan, their radiant energy finally end up when no one fuel is left and fade out. Red giant phase. For stars like our sun, they end up expanding their outer envelope. As for in our solar system, this envelope has prohibitics reach up to Earth's orbit. Supernova type 2a. With stars of mass 1.4x solar mass, they go supernova, stated as Chandrasekhar limit. Further collapse in star is brought to halt by inside denser This creates shock waves confronting outer incoming envelope. This causes an extreme burst of envelope in no time. Supernova explosions are so bright that its energy radiated in those 2-3 seconds are equivalent to energy radiated by a star in its entire life. During this explosion, all the matter formed due to fusion gets thrown out into space, and a very similar process injected matter in our solar system as well. We are made of star stuff. Every element inside us, every iron running in our blood, and every calcium in our bone is from the inside of star. Gamma ray bursts. Gamma ray bursts are considered to be the deadliest explosion of space. Shock waves generated sometimes create intense magnetic field along poles. This accelerates electrons at very huge rate, causing intense radiation emission, particularly in order of gamma ray wavelength. Hypernova. With stars of very huge mass of order 100 solar mass under hypernova. Hypernova is a greater version of supernova. Presently in ETA Carina collection, a huge blue star of 150 solar mass is about to go hypernova any minute or maybe right now. White dwarfs. Formed when collapsing stop at stage with the further collapsion is stopped due to repulsion forces of electrons called electrons density pressure explicable through Paul's exclusion principle. Neutron stars. In stars of greater mass, further gravitational collapse forces electrons into protons, building up neutron density per pressure. Pulsars. Neutron stars carry along huge magnetic field, and with its huge magnetic strength it accelerates electrons within it, causing emission of radiation of version wavelengths. Since in some neutrons radiational axis is aligned along magnetic axis, the radiation seems energetic periodically, just like lighthouse. Pulsars are also called lighthouse of cosmos. Black holes. Stars very huge in mass of order collapse beyond the star of neutron star, forming ultra dense object of space. This dense object have so much gravitational influence that every light cannot escape from its fall. The dispense point is called singularity. Beyond this point, so far every mathematical calculation has failed as a translation star taking place in time than in spectral coordinations. Space blizzards don't end up here. Blue star glares. Although our story of stars formation till demise might have ended, but recent discoveries have shown mankind the most bizarre and perplexing nature of universe. Binary stars. Unlike our sun, many of other stars in our galaxy have a comparison star. Often one star goes under demise stage before forming white dwarf, neutron star, or even a black hole. The companion dead star pulls away the material of other star, accelerating around it in front form of a disk. This acceleration process very often causes overheating, leading to a nuclear burst on its surface known as nova. So don't confuse nova with supernova. Supernova type 1a. The accelerating mass around dead star when finally reaches a critical stage of mass and no mass is added further, it goes supernova. Recently observed supernova in February was type 1a supernova. Supermassive black hole. Generally found in the center of spiral galaxies, this black hole are of mass order million, means massive than our sun. So that's it guys, that's the end of the video. I hope you like the video. It takes a lot of time for me to make videos for you guys. Please do like, subscribe and share to my channel. Thank you.